It's just traditional, so that's what I'm going to do. And the other thing is, a lot of times people get the order mixed up. Quadrant 1, what is true of all ordered pairs in quadrant 1? What kind of numbers are in quadrant 1? If you look at coordinates A and B, what kind of numbers must their coordinates be? Okay, maybe you would see this if we wrote down the coordinates for A. What are the coordinates? This was the first question on the investigation 7. What are the coordinates for point A? Allie? 3, 1. So you say 3 with a pause, 1. You can say 3, comma 1. Okay, 3, comma 1. What about for B? I thought you guys said that was easy. Somebody other than Allie. Feel pretty good about her work on this one. 1, 3.
Yeah.
Now they just flip-flopped, right? Clearly, two different places. So, first thing to notice, it does matter what the order is. Second thing to notice, they're both what kind of numbers?
Positive.
Yes! Positive. Are you positive about that? Yes, they're positive. Let's contrast that with over here in quadrant 2. Here's what I want to do. I want to put a plus here. Okay, quadrant 2. Well, let's look at C. What is C at?
1, negative 3.
No.
No, negative 1, 3.
Negative 1, 3. Good, Carter. So left is a negative motion. On a number line, when you move to the left, you're subtracting. That's what we need to associate here, is that moving to the left is a negative motion. Moving up, however, is positive. So for quadrant 2, we're going to say minus, comma, plus.
Negative 3.
In quadrant 3, can you already see what kind of numbers exist there?
Negative 3, 1. Negative 3. Negative 3, negative 1.
Negative 3, negative 1. They're both negative. And then over here in quadrant 4, look at H.
Negative, positive, no, positive, negative.
Positive 3, negative 1. So I move to the right 3. That's a positive motion. I move down 1. That's a negative motion. They should all be different. Plus, plus, minus, plus, minus, minus, plus, minus. All of these are in what order? You have an X coordinate and you have a Y coordinate. So we want to begin associating, again, horizontal with X, vertical with Y. And that understanding will be really easy to solidify when you do the delta math, okay? That's why there's so many of those. Some of those have like 10 problems in them because they're fast. And I want you to build something automatic. The only way to build it, make it automatic, like free throws, is to do it a whole lot. Okay? All right. So, coordinate plane stuff, I guess that's kind of ironic that one of the pictures was an airplane. It's a coordinate airplane. Maybe it was. I'll have to look at them and see. All right. So there's your lamp, right? Doesn't show a picture of the other one, but I saw an airplane. So don't wait till the last minute to start the delta math. All right. So let's take a look. Yes, keep your trapezoid for right now. I want to take a look at lesson 70. Okay, lesson 70. So we're going to take some notes. So lesson 70 is about reducing fractions. Oops, not multiplying. Reduce and then multiply. Multiply or divide. All right. So reduce and then multiply or divide. Reducing fractions is something you've been doing for quite a while. If we take a look at one of the examples, suppose you were asked to find 5/6, the product 5/6 times 1/5. Okay, said another way, find 1/5 of 5/6. When you're asked to find 1/5 of something, we're just multiplying by the something. 1/5. So the object here is to see, well, I could do this by multiplying straight across and getting 5/30. Okay? If we don't reduce first, right, but suppose we see the relationship that I have 5/6 times 1/5, and you have a 5 on top and a 5 on bottom. So before you multiply, you say, well, I know that those are going to cancel, aren't they? And if they cancel out, what's left?
1/6.
What is true of 5/30? Does it not reduce
It does.
to 1/6? So the goal here is not do it as fast as possible. The goal here is to see the relationships that you can use. Okay? So one of the other examples, let me do from the... Suppose we are asked 5/6 divided by 5/2. You mean we could do it in division problems too? Yes. Because we're not going to divide. We're actually going to Kentucky Chicken Fried. 5/6. We're going to change it to multiplication. We're going to flip it. So it becomes 2/5. Now, pay close attention to what you can reduce or cancel. Notice we'll have a 5 on top and a 5 on bottom. What happens there? They cancel out. But remember, they cancel out because 5 divided by 5 is what?
1.
All right, so there's really an understood 1 here, and there's an understood 1 here. That's what cancellation is. I want to make sure you understand that, because a lot of people will think there's a 0 when you cancel out, and that's not true here. The cancellation is dividing a number by itself. Here, is there anything we can do with the 2 and the 6? Does that reduce or cancel? One third. 2/6 reduces to 1/3. So I have 1 times 1, which is 1/3 times 1, which is 3. Can you get the same answer if you don't reduce at the beginning? Yes, but you'll have to reduce at the end instead. Okay? So to show you that, let's work it out that way. 5/6 times 2/5. So that would be 10/30. And then maybe you see, oh, that's really easy to see. That's going to reduce to 1/3. Now it comes down to personal preference. One of these ways is not wrong compared to the other. They're both correct. But it's going to be incredibly helpful for you to notice the relationship, okay, Grayson, that allows you to reduce early because it shrinks everything before the end of the problem. Okay, questions? So lesson 71 is where we'll focus our last few minutes. And I know you might think you know everything there is to know about parallelograms. Like how to spell them. Ooh. You hate spelling.
So is that the end of lesson?
That's it. That's it. Lesson 70 was very brief. Okay? And that's why we're joining 2 of them, okay? All right. So there's a few things that we're going to have to make sure we draw. And if you don't use straight lines, that's okay. Okay? But look, parallelograms have some very specific relationships. Okay? I'm going to introduce or maybe review some symbols here. Okay, the first, you know that they're called parallelograms because they have 2 pairs of parallel sides. So here's one pair labeled, okay? The other pair, we're going to use 2 to show that those opposite sides are parallel, all right? So now you can see it's definitely a parallelogram, but there's some other things going on with the angles, okay? So yes, we know that opposite sides are parallel, 2 pairs in fact. What you may not know is that opposite angles are also
The same.
equal. So I'm going to color code these for us. And then these are not acute, but these are obtuse angles. Those are also going to be the same. Okay. So not only do we have two pairs, characteristic 1, two pairs of parallel opposite sides, okay? Two pairs of congruent angles. Have you heard the word congruent before?
Yeah.
Now pay attention to where they are. They're also diagonally opposed, okay? So, diagonal, you see what I mean by diagonally opposed? Those are diagonal and therefore congruent in the parallelogram. These are diagonal and therefore congruent. Liam, question?
I was going to say something. Well, I was going to show something.
All right, hang on just a second, okay? So, here's the thing. If one of these things is true, then the other is true. Okay? Think about it like this. If you're not an only child, then what is true? You have a sibling. If you have a sibling, then you are
The favorite child.
not an only child. Do you see how one makes the other true?
I'm going to have two.
You see how one truth makes the other true. Same thing here. If you have two pairs of parallel sides, then it must mean that the opposite diagonal angles are congruent. Because each of them individually creates a parallelogram. Okay? So we could add numbers in here to make this a little more fun. Or maybe not fun, but maybe more clear. You know, for example, if this angle, let's make this angle 80 degrees. I can give you one angle, and you should be able to figure out all the rest. Now, there's one thing I haven't told you. Cora?
Can I go to that?
Yes. There's one thing I haven't told you.
Angle C.
I haven't told you all three of those, but there's one relationship that I need for you to focus on, okay? Front row? Hold up.
I know.
What is it, Liam?
How you get the angle is you subtract the 80 from 180. That equals the other angle.
All right. Did we learn what that was called when you have two angles that add up to 180 degrees?
We did. I just can't remember. Vertical angles.
Angle D plus angle C equals 180 degrees. You see, the third thing and final that I'm going to have you write down is that adjacent angles are supplementary. And that means, by definition, they add up to what?
180.
Good. So we're going to put the sum equals 180 degrees. So, if you know that angle D and angle C, those are adjacent to each other, adjacent just means beside, then you can infer or calculate that C must be 100 degrees. Then you could fill in all the others. That must be 100 degrees, and that must also be 80 degrees. And that's it for parallelograms.